All right, hello everybody. This is Antonio Wolf here with my good friend Avalonia, who's done something pretty exciting in my opinion. He has gone through the philosophy of nature, and not only that, he's kind of gotten the lay of the land of current stuff in modern understandings of science, as far as they are relevant on the broadest general categorical scale, and he's cooked up an outline of how the philosophy of nature, in a Hegelian sense, can be updated. Uh, so here on my screen, I just copied over the thing that you had posted in the Hegelian chat, Avalonia, with the
Mhm.
outline. So that'll be on the recording. Actually, let me share the screen for other people here on the stage.
Mhm.
So for those of you who want to follow on, like what are you talking about? Here's what we're talking about on the screen.
Right. Uh, so, uh, to give a bit of a preliminary remark about uh, a what exactly is intended for a philosophy of nature, there are essentially the modern approaches and understanding in uh, natural philosophy has essentially been, in the one sense, um, prior to contemporary philosophy, been essentially concerned with understanding a metaphysics of nature, but this kind of metaphysics is something that is more ontological, more categorical, uh, which the question arises, um, well, of course, how do we know whether this ontology or metaphysics is essentially true? Uh, what how would we essentially know that a certain supersensible conception of nature is something that is that we can know or counts as scientific knowledge? Um,
Mm-hmm.
and in the modern sense, there has been a uh, more of a skeptical distrust, and well, there have always been skeptical periods in the history of philosophy generally, um, but more in the contemporary side of particularly through the 20th century on, has essentially been uh, a more of a critique or formal critique into uh, the natural sciences, um, either into the one of two sides, essentially a overly formalistic conception of the natural, where when we investigate nature, we come up with uh, certain theories which essentially have to do with bringing together phenomena under certain laws and formal structures, such as certain equations that express equivalences and so on. Um, but also at the same time, there has been another push on a purely experimentally motivated part of science that while taking the theory for granted, essentially just focuses on the more empirical side that it has to just do. Nature just has to do with observing things, and that we can simply just know things, but if we can. uh, investigate uh, the empirical or given closely enough. And
Mm-hmm.
this structure of nature, uh, the problem that I have with both of those conceptions is that even though they are in their own right, in their own sphere, um, essentially performing some necessary part of science. There's not a holistic view, there's not a conceptual view that would actually bring um, all of these moments not as just arbitrary classifications, but a classification that is not only logically necessary, but um, shows rationally how each moment uh, develops out of the other, logically speaking, that it has to do with the actual thought of the thing uh, developing itself, uh, which is to essentially say, from the standpoint of nature, um, nature it is up to nature to tell us what nature is all about. And
Mm-hmm.
so on this side, there is an objectivity to it that nature it has an independent sort of um, logic and that determines uh, what it is, but that also this logical is knowable to us and can be articulated essentially. So
Mm-hmm.
in the first part
Actually, could I comment a little bit on just like to clarify for other
of
people who
course.
don't have our background, that when you're talking about this about how nature develops itself or reveals itself, or earlier about like how the categories or the ways in which nature appears to us, develops itself like organically, one thing from another, like how the most obvious thing would be like how life arises out of inanimate nature, right? Where we see that clearly it has happened, and the question is why and how. And then the usual things where we just kind of take it for granted these days. Oh well, evolution. Uh, and the how is a simple thing about we can either talk about genes or we can talk about like perhaps more advanced stuff like say morphogenic fields or whatnot, and they still kind of remain the physical. And since we seem to say like, well, we have come up with some kind of mechanism by which these things could be structured, we think we have actually explained why these things or even how these things have actually arisen. It's a kind of like it's a correlation that works, right? Just like
Mhm.
mathematics in physics, where we have an equation for gravity, and well, it works. And people become mystified by that, and it's like, oh, well, we understand gravity now. When no, that nothing of the case has happened, right? You have a mathematical equation that doesn't really tell you what's going on. It just tells you, well, there's certain quantitative relationships, but we don't really know what's going on. We don't really understand what gravity is. We don't understand life just from simply understanding that, well, there's some kind of process we call evolution, in which matter somehow comes together and gains this new quality of being alive. Of course, there are people who will say, well, there is no such thing as being alive. It's just an illusion. It's all just like basic physics and chemical stuff. Um, so to give the example, I think that the easiest one is the very beginning of the philosophy of nature, right? Where we have the derivation of space and time. Because a lot of people are like really, really confused about that, especially in physics. Like this is like one of the most important things. What is space? What is time? Because everything else works within space and time in physics. And we have all kinds of like really crazy views. I can't remember right now the name. It's a Italian guy who's really famous right now for being like, oh, time is just an illusion of entropy, right? I think. Do you know? I think it's Ravelli. Do you know who I'm talking about? I think
Yeah,
it's
I think that's Ravelli.
yeah, Ravelli. And his whole thing is, oh, well, it's just a thing that's downstream from entropy. And yet these people don't notice that entropy is literally defined in such a way that time is already cooked in. The arrow of time is already cooked into rising and lowering entropy. It doesn't actually answer anything. Or these other like weird theories, right? When some people say, oh, space and time somehow just quote unquote cascade or derive from these pure mathematical equations. You're like, well, that doesn't. You might be mystified, if you're not somebody who's a little bit aware of what goes on in those fields. By this, you're like, oh wow, the world is weird. Somehow everything's ultimately math. But if you just think about like, well, wait, how does that even make sense? So you have a bunch of equations, and all of a sudden, we have this domain of that we experience as space, this extendedness. And when you look at the math, well, there's nothing in the math that actually leads anywhere to that at all. Like neither as numbers nor as experiences. We just kind of correlate these things, right? And this is what Hegel's like philosophy is trying to break out of these weird illusory answers that we have, in which we take A here and we want it connected to B there, and because we find some way to justify ourselves like the appearance of a correlation, we think that we've therefore made an explanation. But for Hegel, that's not good enough. So I would give the example of space, where space is just the simple intuition that you have of space. It's extendedness, outsidedness, no further qualification of that kind, just in a very simple way. And Hegel says, in Hegel's beginning, it's just, well, okay, well, so let's just take space as that. That's what we mean. How does that even work? Could you have space considered from beyond space? What would space look like if space had no other space in which it was within? Non-spatially, if you stepped somehow outside the dimension of space, hypothetically, would you be able to see space, right? Well, no, it'd be zero-dimensional. As a matter of fact, you couldn't even say it's zero-dimensional, because like it's not a point outside of you, because outsideness is already being in space. So that wouldn't work. And if space itself within itself had no further divisions, no dimensionality, it wouldn't appear space at all. It would be zero-dimensional, but then zero dimensions without distinctions is not even zero dimensions either, right? It just wouldn't be anything. So Hegel's like, first things, well, in order for space to even be spatialized as zero-dimensional, you at least have to have this division of space, from one point to another, which will require at least one dimension, putting the representation of geometry, the line. But obviously we live in a world that's not just points. We don't just like experience points, or even then, like, visually or like rationally, it's kind of be weird to talk about the points, because like by their own definition, they don't properly exist. They're zero-dimensional. Hegel says they're just idealizations. They don't concretely exist. In that relationally, we can talk about points from one part of space to another, but as a point as such, there is no point. Just like Hegel will deny there is such a thing as atoms in like the indivisible form of matter. So anyway, so you have a point, and in order to have a point, you have to have at least the division of one point from another, which requires the line. And we live in a three-dimensional world, so we at least have to have more than a line. We have to have planes, and in order for a line to even be a line, to stand out as a line in a spatial way, you need to have a plane, a two-dimensional domain in which a line can be divided from a line. And then in order to have the plane, you have to have a three-dimensional domain, the volume, in which a plane can be divided from a plane. And then, as far as the derivation goes, Hegel leaves it as at the volume, at the third dimension, because, well, as far as it empirically goes, we don't really need anything else. Even though, there are some speculative in the like just merely hypothetical sense of that, 4 dimensions might just kind of be better. I don't know if you've ever looked into that at least, for example, I think the fourth dimension has 2 more Platonic solids in the third dimension. And then after like the fourth dimension, every dimension afterwards just has less and less. And that generally has about like 2 or 3 at most. So there seems to be something special about the fourth dimension of spatiality, if we took it that way, that would probably be more perfect as far as like the qualities of motion and the ways in which things can relate could be the case. That's just something I find very interesting. But but anyways, so I mean, it's very simple, right? So in order to have a point at all, like a point outside a point is a line outside a line is a plane outside a plane is a volume, and then you may ask, well, what would a volume outside a volume be? Well, if you were talking about dimensional things, we would just call that whatever we call a 4D. Um, but since we don't generally need that, the next best step is, well, what would it be for a whole of space, which would be a volume, to be outside another whole of space? But this time, well, I already said it. In this way, it would not be spatial. So, but there is a form of externality, of being outside of itself, which is not spatial, which we do understand, and that's time. Time is like one whole frozen part of an image. Let's say it's like the film analogy, the film strip, where you have in a movie you have the slices of film, each capturing one moment of reality. Each one of those would be like the whole of one totality of space, one universe, let's say, and then it would be one frame, and then the next one would be another frame. And this division itself, which is not a spatial division, is the temporal domain. And then Hegel has that happen again, in which says, well, what is the externality of temporality? How is it that time is outside of itself? Well, the way time is outside of itself is as moments of time. But what are the moments of time? Well, the moments of time are just these totalities of space. So you go from zero dimensionals of points to the volumes to time to the moments of time back to the dimension of space. That's how Hegel presents the way in which space develops its dimensions and develops into time, and time redevelops space. So that's to give an image. And I know that's like, for those of you listening, that's pretty abstract. I would suggest that you just like draw it out literally, like play around with that, like open MS Paint or get a piece of paper and like just follow along. Put a point to a point connected. Consider that in order for a line to be present as a line, it can only be present insofar it's divided from one line to another, which at least requires the plane. So draw a line next to a line. There you go. You have the square. Connect them, and then you do the next one, which is the volume. Which, of course, in a drawing, you could only do it prospectively as a drawing. But you could also just like see that for yourself. Put a page on top of a page or whatever, and you can see that division itself is a new dimension. It is that simple. Like it conceptually, it's very abstract, yes, but at the same time, it's as simple as understanding that a negative times a negative is a positive, or that no is yes. It's that kind of thing. Anyways, I'm sorry. I just wanted to make that little addition to help people clarify. Maybe it didn't clarify, but I think it does help a little bit.
Yeah, no, I thought it was made a lot of sense. I think that the way that you know thinking about the concept itself, or uh, thinking conceptually, it is a skill like any other kind of skill, and it people who either don't have the intuition for it or haven't um, practiced thinking or with metacognition, it's not. It can seem strange and unfamiliar, but that's kind of just how exactly something develops itself um, uh, rationally. It is something that it's just articulating its logic from its own standpoint. So uh, what I think is more specific about the kind of work that I've been putting together for this is uh, particularly for the real philosophy in Hegel's system. where it goes into uh, nature, and then the moments of spirit, subjective spirit, objective spirit, and absolute spirit. Um, these in themselves exhibit the moments, essentially uh, recapitulate the moments which are expressed in the logic uh, as in effect in each moment developing from quality to quantity and to measure in the dialectic of being, and then uh, subsequently to the essence of the subject matter, where it has reflection, appearance, and actuality. And then there is the dialectic of the concept, which has the subject or concept, the object and objectivity, and the idea, which is the unity of subject object as truth. And in each of these stages, for any subject matter which can be comprehended as a dialectical totality, um, it does this uh, essentially um, on its own, that it uh, in rationally articulating about how the concept develops, there will be each moment which uh, supersedes the previous moments as pointing to a something that is negative or mediated, that logically implies the next step. So kind of the metaphor for thinking about this is, um, in some ways you can think about like uh, the seed growing into the mature plant, which then posits the or grows the seed that implicitly has the whole plant, or like, the layers of an onion. There have many layers and has kind of a core to it, or uh, like Russians stacking dolls. Like each the prior preceding concepts are sort of contained within. So there's a process of totality and development.
Mm.
Uh, but from the standpoint of nature, the division, or essentially the beginning uh, of this, has to do principally with what is the pure mechanics of uh, nature, where the only ontological categories that we're dealing with are, so to speak, purely the categories of like space, time, and motion. Uh, just to say that of the immediate uh, quality that nature is. So this is, the very initial or beginning concepts that essentially structures the rest of the concepts that take place thereafter. Because in order for something to actually be, say, a body in motion, or to have a dynamic system of bodies, then all of these um, bodies, their motion, their velocity, their masses, they have to first be spatio-temporal. They have to be instances in space and time, and to have something that expresses motion, um,
Mhm.
which uh, one of the reasons why um, uh, dynamics is essentially the quantitative uh, moment of nature logically is because like in the logic there is uh, essentially dynamics is in the one sense an ideality or something that has uh, a sort of something which is always mediated, like in quantity. Like when someone talks about uh, there is three of something, or there's two-thirds. There's not something we can just point to out there spatio-temporally, like this is a three, or this is a seven. Uh, it's something that it's always, so to speak, mediated or ideal between real things. So like um, we don't just point to three, we point to like there are three cows or there are seven plants or uh, something like this.
Right. Even with
And
the pure numbers, like we can't do that, right? Even when a three is already a multiplicity of units, 3 units. So.
Mhm. Yeah, and my description of dynamics is that uh, dynamics or classical mechanics is essentially the same way. Like if you essentially have the parameters, say, of uh, the positions of bodies, their velocities, their masses, and there's an interplay between velocity and mass as a persistence of motion in of a body and resistance to motion as mass. So this sort of interplay is uh, necessary if bodies are in effect to maintain their motion, uh, as well as impart differences of magnitude of motion uh, between each other as differing momentum.
Mhm.
And from there, essentially, you have a notion of uh, moving bodies which themselves have a uh, not just a persistent motion or velocity that proceeds into magnitudes of displacement, uh, like for instance, when you pull like if you were to have something like a spring, the uh, the thing which is attached to the spring, like a ball or something like that, uh, in actually pulling the spring, the ball itself is displaced. So there is essentially a persistence of motion that is uh, combined or coupled with displacement. So there is essentially a compliance in between the thing and the spring as part of its potential or potential energy. Uh, but there is also at the same time a resistance to that motion on part of the mass of the ball attached to the spring. So there is essentially you have a greater inertiance of bodies differ in magnitude, um, which require a greater uh, quantity of motion to be uh, imparted to it, so to speak. Uh, so, at least from this standpoint, in between the in between the compliance and the inertiance of the the system, this is actually a self-reinforcing activity which appears in oscillation, as there is a mutual soliciting and solicitation of motion, which is maintained in the movement of that system itself. And when you grasp this recollectively, this mutuality of motion, uh, you then begin to see there is essentially an elasticity or elastic motion, where you're not simply considering just the dynamics of the bodies which are involved in motion, but essentially how the whole of the thing, uh, the bodies are essentially uh, held together, so to speak, uh, 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 elastically. And this is something that immediately gets into the notions of relative motion and relativity, because once you're not just talking about the standpoint of just one system of bodies, but how there exists, say, an elasticity between um, different systems of bodies, which are also in motion within themselves and move relative to another. So you have, uh, from the standpoint of elastic motion, you have, in a sense, an origin of what conceptually something that amounts to what gravity in effect is, because with gravity, you're
Actually,
it's not.
could I stop you there for a bit? So do you
Yes.
think you could you give us like some kind of like a more visual or concrete example, say what's going on in dynamics with inertia, impact, and elasticity?
Yes. So in for inertia, right?
Hmm.
There is essentially, you're immediately looking at the motion, so to speak, of a body, for instance, um, if a for instance, a soccer ball, for instance, if that's kicked, that it has a certain, while it's moving, there is a persistence of motion in it. It has a certain, um,
Hmm.
it'll have a certain velocity when moving. But also, because there are uh, bodies which are uh, differ in degree of magnitude, there will also be a greater degree of resistance to motion that is imparted to them. But at the same time, there is essentially, in between persistence and resistance, you're essentially looking at that degree of motion isn't something that is changing. They are both, so to speak, uh, inert to each other. So,
Mhm.
and this isn't something that can really appear, uh, say, for instance, in something like, uh, say, for instance, like the acceleration of something or a changes in degrees of magnitude in between something like where you actually have uh, more than one body which influences each other by way of impact. So an example of this, um, the kind of classic example where you have elastic collisions of bodies, like billiard balls, for instance. That's kind of one example, depending on the kind of the quantity of motion imparted to it, where you essentially have um, uh, a source of momenta which is applied uh, to the body of that system
Mhm.
that, in effect, is carried over and uh, passes over in being uh, displaced, but it can only be displaced, so to speak, if there is uh, something there uh, in the way of having a uh, resistance, so to speak, to the thing impacted.
Mhm.
So,
So understanding this correctly, if we took inertance absolutely, it would be like a perfect momentum transfer from body to body, where like the body itself would be like uh, not perfectly elastic, it'd be perfectly rigid. So there's
mhm.
no deformation, none of that. So the energy would just have to be complete transferred to the body as a whole. So it'd be like the perfect billiard ball scenario. Compliance here, would compliance include not only the possibility of the deformation of the body, so that energy is somehow differentially transferred to some kind of deformation of the body, or and would that actually also involve like would deformation or compliance here also involve say something like what happens in heat transfer, in which like the energy is not being transferred to the body as a whole, but only to a certain portion of the body in relationship internally to itself?
um, yes, but there, so to speak, with the notion of dynamics and impact, at this moment of analysis, the specific instances of compliance and energy transfer, like say in between electrical bodies, thermal bodies, the kind of specific particular kinds of transfer uh, cannot yet be articulated from this point. But I do agree that, but with the examples that you brought up.
Okay, yeah, it makes sense. And then it makes sense how from compliance, this itself would be a sort of kind of inertance which would return to the whole body as a whole, and you would have this kind of oscillating aspect to it. It makes sense.
Mhm.
Right then, sorry, you were in the middle explaining elasticity.
Yeah, and also onwards to gravity as well, uh, because it's quite interesting with at least from the standpoint of elasticity and gravity, because there is a kind of a core, so to speak, that is a rational core, so to speak, that is common to various different theories of gravity, which actually have some kind of mechanical explanation to them as a base, um, essentially deriving from and presupposing uh, elasticity, uh, where essentially to say that you are treating recollectively not just the uh, momentum and energy of, say, this particular system or this particular um, body, but you are essentially looking at it universally, where you know it's not just uh, like it's not just the harmonic motion of, say, this system or that one, but from the standpoint of gravity, you're looking at um, uh, the motion of the whole. So, for if you were to say investigate the notion of the whole of mechanics, say the universe, the cosmos, as itself something which is uh, oscillatory and elastic. Its internal movement would produce regions of space, volumes, where its motion effectively is uh, self-canceled. And this is essentially where the centers of mass and matter exist, or where it's in effect concentrated. And there are certain uh, notions, so to speak, of uh, trying to figure out, in effect, um, what gravity is. Uh, and at its core, uh, I would say that in its purest form, it in effect has to do with the synchronization of motion or frequencies in the bodies themselves. And this is actually, in fact, something that um, there is another real uh, phenomenon of this called frequency pulling, where there's an external wave source that disturbs an oscillating body. It causes shifts in its frequency to shift towards its source. And interestingly, this is something that also appears in a lot of electromagnetic phenomenon, in particular, lasers. That the lasing frequency is something that is pulled towards the maximum of the curve, and it is actually something that resonates. So you actually have this notion of gravity, um, in effect, having its origin not simply just in the elasticity of bodies, but also their uh, uh, differences in frequency that, in effect, allow for the formation of gravitational systems, such as and there are different say forms in which that can exist, um, depending on whether if you have something a massive body like a star and kinds of bodies which orbit it like various moons and comets, and whereas you have something like a planet as something that not only is a gravitational center itself because it is capable of having moons, but it is also something which orbits um, another body, a star, and at least from that standpoint, it is possible to uh, articulate laws of orbital motion that uh, arise from this. And I believe in actually in the original philosophy of nature, the first volume. This is Hegel goes into a lengthy digression about the difference between the gravitational theory of Newton and of
Kepler.
Kepler's laws. Um, and that's definitely a whole discussion in itself, as how
Mhm.
exactly um, there arise the in effect celestial mechanics of the different configurations of uh, gravitational orbits and such.
Well, I mean, yeah, I think we comment on it a little bit. As I'm aware, part of the core of that critique is that Newton's mathematical generalization is, in Hegel's view, a false generalization. General in the sense of being generative. Because, I forget what the exact little formula equation is. Let me just look it up. Newton's equation of gravity. Law of universal gravitation. Which is force equals G times m1 times m2 over r2 squared. That, even though it does work for most cases, that we need them for on Earth at the very least, that's not truly a general equation in that it doesn't generate anything. In order to make that equation work, we as human beings have to modify that equation in every instance to put in the proper masses, put in the proper information. From the masses, we can't get the distances. From the distances, we can't get the masses. From just like the abstract force, we can't get, the masses or the distances for the radius. So, in that way, Hegel kind of hates Newton for pretty much providing an illusion for physics which has not escaped to this very day. And he actually praises Kepler in that Kepler has specific solutions for specific problems and does not claim that these are universal. Doesn't claim to have a universal law of gravity because he doesn't. He only has, the laws of the orbits, what we could say, of the planets of our solar system. And Hegel thinks that what Kepler does is truer to what the actual fact of what we know is, as opposed to this illusion provided by mathematics, which Newton came up with. And funny enough, Newton's type of equations are called dynamic force equations. And they're dynamic in that you can contextualize them to most situations within a certain domain range. But even then, they're not truly dynamic because we're the ones who have to modify them every single instance. They don't produce any dynamism of their own.
Yeah. Uh, yeah, I agree. I think that at least with regards to uh, Newton and Kepler, per his Hegel's comments, um, the basically, I would say it comes down to one of the issues in even when it just comes to laws and the phenomena which are supposed to be explained by the laws, then it kind of falls into uh, it being kind of a tautology, something which is referential to itself, but not in such a way that it actually uh, specifies what it is or what the problem is on its own account. Like it's something that we have to do, say, after the fact, once you know the actual parameters of some concrete problem has been specified. You know, um, so yeah. Um,
So let's see. We can continue on. So you explain celestial bodies. Let's go on to orbital motions and then polarization. That's
mhm. Yeah, and this is something that's actually one of the more interesting parts of the investigation of my research that I've been looking into. That uh, relativity and general relativity, in that case, at its core or its essence, is in effect indistinguishable from the optical equations of motion, and there is a uh, a, uh, a reason for this, uh, that uh, well, in particular, there are various sorts of. Oh, wait, hold on just a second. I'll be right
mhm.
back. Real quick.
If any of you have any comments or questions, go ahead and put them on the side chat. By the way, we'll try to get to them once we finish going over the outline.
Yeah, so sorry about that.
Yeah, no problem.
So, yeah, so essentially what I was saying about the uh, there is essentially a common thread between um, uh, relativity and optics, in the same sense that there is a refractive index of relative motion, which can be likened to the of what has been described as a bending of the or bending of things present in the gravitational field. That a
Hmm.
gravitational field can it is in effect indistinguishable from a refractive index, so to speak, um, of space. Uh, and there is in effect, some work on this that I have been investigating. That um, there is certainly uh, uh, no mistake with regard to uh, the origin uh, of special and general relativity as having a common origin or reference point from uh, light itself, as the standpoint of light being the kind of the, so to speak, absolute uh, uh, reference frame through which these different sort of relative motions and activities are measured. Where in trying to uh, the phenomenon of uh, length contraction and time dilation um, don't quite make sense without uh, some kind of uh, uh, structural uh, uh, notion of, say, uh, varying a variation in the momentum and energy of the bodies uh, thereof. So, and this is something that's pretty interesting too, in trying to uh, develop uh, an explanation as to what redshift uh, even is. As in, why is there even a uh, you know, how is it even the case that uh, redshift is something that even uh, takes place, and you can't really uh, have that kind of notion, because if you don't have, um, say, some sort of, uh, for one, metrics of uh, space and time, and uh, if you have, uh, say, different observers measuring the energy and momentum from their own reference frames, they are uh, located in different regions of space and time relative to um, the light source. Uh, so, uh, in effect, there is not only a a new unifying uh, concept of light and electrodynamics as something that is seemingly a transcendental to um, relativity and gravitation, but is also a reference concept upon which they uh, depend on as conditions. Um, and this is something that I think is true, even um, if you were to closely examine the various kinds of theoretical issues in uh, cosmology. Uh, in effect, referring back to this concept. Uh,
All right. Um, could you give us a rundown how we go from orbital motion to polarization? That seems interesting to me.
yes. So, uh, in effect, if you have a different a gravitational systems, say, which are defined uh, by, there's a distribution of bodies, of masses, and spatially uh, differing in extent, that from the standpoint of uh, their uh, gravitation of that whole system is something that can be uh, determined. But from there, the problem here there is you know uh, gravity becomes something that is uh, also itself simultaneously universal, but also something that is expressed particularly or relative to um, the uh, celestial systems. Um, and this is something that is uh, from the standpoint of the universe uh, itself, that there is uh, an acceleration of systems which is not determined by um, the motion of the different systems themselves, but is something that is uh, intrinsic to, or is a property of um, uh, the universe itself, as something which is um, not an ideal emptiness, but is something that is in itself substantial. Um, and the way in which this uh, substantiality is expressed has to be something which, if there is a apparent distinction between, um, say, how there is an apparent distinction made between how, say, uh, matter and mass uh, so-called bends space or space-time, and this is kind of the way that it's uh, kind of described formally. But you know, there has to actually be a concrete um, notion of what uh, something such as uh, uh, space-time is, as you know something like it can't simply just be a um, transcendental concept that is left unexplained. Like there has to be some notion of uh, the groundwork of space and of the universe um, having itself something be something which is capable of uh, uh, expansion and contraction. Uh,
Right. Space has to be material in some way, right?
yes. And the notion of what I think this uh, materiality is is that at its core, it is something which uh, has to be electromagnetic as expressing a uh, something which is at once divided into a uh, positive and uh, 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 negative poles. And you can kind of think about this like um, in a certain sense, you can almost think about this beginning as almost uh, a kind of inversion of uh, the idea of space in itself to being something which is closer in effect to uh, Leibniz's idea of monads, as there are opposed states, so to speak, which are relative to the or mirror, say, the other states that are expressed. That this isn't something that is just um, something that is you know something that is extended or extensional, but has to be something that is mirrored um, uh, in itself to even uh, coordinate or be the cause for, say, the distortion of space and of matter. And this is uh, something which leads to the immediate phenomenon of um, electromagnetism, because you're actually dealing with something that of space having a an uh, electric permittivity and or permeability and susceptibility, as both from that standpoint, uh, you have almost a notion of, if you take uh, that uh, electric field space itself, uh, you have a almost a potential gradient of positive and of negative charge, where it actually becomes something that can be, in effect, um, accelerated in accordance with that potential. But if, say, an electric field or a magnetic field has something to even affect, um, whatever the actual body is must also be uh, constituted um, effectively uh, of that space. And in the way of particle physics, this is something that is kind of what is talked about as the distinction between um, what are called bosons or force carriers. These being, in effect, you can kind of liken them to uh, different manifestations uh, of light, where there is essentially a groundwork of uh, the uh, electromagnetic uh, force, which is essentially something that is um, ontologically primary and uh, something which uh, conditions the uh, appearance of uh, the strong and weak forces, which are indeed uh, real forces, but they are conditioned by the electromagnetic uh, uh, force because the particles themselves uh, have to be, in the one sense, uh, electromagnetic because uh, effectively this would be amount to saying that they are a essentially a self-enclosed um, uh, vortex, you could say, of light. Uh, and this is something that is observed in pair production and production of um, particles generally, from fermions uh, to bosons.
Hmm.
And you know, uh, within itself, there is essentially uh, specific configurations or harmonics of that of say that original wave. Uh, like, and this is, by the way, one of the reasons why the whole notion of um, wave particle duality has been something that has been so mysterious to some people, when in reality it's actually not really that mysterious at all. If there's a ontological primacy of the wave, there's a unity, so to speak, uh, of the original space of the quantum potential, and there are uh, excitations or uh, uh, harmonic formations within that wave, which is expressed as an appearance of the as the particle.
Actually, to go back a little bit, because either I
Sure.
missed it or we kind of skipped it. Oh, what is light itself uh, in the
Oh,
categories that you're using?
yeah. So light itself is, in the first sense, I like it. I liken it to something that is the non immediacy of nature, something that is in effect um, essential to it, and is also uh, in effect uh, conceptually identical, I would also say, to uh, the monad of Leibniz. That, there is essentially a division between the image and the imaged, where light images space, and space is imaged by light. There's the image posit. It posits what is imaged, and the imaged is in being reflected, reflects and also posits its image. So you can kind of see there is um, a reciprocal activity that is produced by this. originally in the activity of uh, uh, of light, which is something that is quite is quite interesting because at least when thinking about what uh, light is, as electromagnetic uh, radiation, there is in effect different contexts in which light is studied that is particularly something which is always essential
Okay.
or non-immediate. Yeah, so yeah, there's a lot of interesting things about light uh, as well uh, conceptually. Even although this is something that doesn't uh, quite appear at this moment because light is something that also uh, requires some composed materiality, which is something that appears later on in the philosophy of nature, the chemistry part, where you actually have some specific notion of uh, light emitted as radiation as a consequence of energy level transitions, but also something that behaves uh, differently in different materials. Like you can have opaque materials, transparent materials that reflect some parts of light. And interestingly, if you look at the experiments of Goethe after Newton, that he has a certain investigations into light, and I believe Hegel also talks about uh, him as well. That essentially with Goethe you have a original um, the formation of colors as the interplay between um, uh, light and dark.
And by dark, he
That
generally also just means matter. Like, that's
Mhm.
what it is.
Oh yeah,
Yeah.
yeah, no, absolutely, and I think that's um, also something which this is also something that I think kind of uh, is also part of the distinction in physics between like uh, bosons and fermions as kind of recapitulating this difference between um, free radiation and more rigid uh, uh, matter, because you in effect have something which is um, in a certain sense almost recapitulates the original oppositions between um, compliance and inertiance, but it does so in a different way because, when talking about something that is um, bosonic or radiation like, um, you're speaking of something originating from that, uh, in effect, force that originally, so to speak, is always mediated between that which from which it's emitted and which it is absorbed, which that in turn presumes that there are actually um, rigid or inert things which actually, so to speak, are constituted by this interaction, but also determine it, which this in turn is something which is, fermionic or uh, as in, the kinds of particles. There are like uh, electrons, hadrons, uh, uh, for the most part, kind of, at least in the sense of the vast majority of uh, chemical interactions that there are, this is something that is, uh, between, nuclei and electrons, or at least those that are constituted that way. Um, but in that sense, there is, uh, you know, but that itself would have to presume a prior background of a prior background of how exactly the force in question, electromagnetism and the different uh, strong and weak forces are able to uh, interact in that way.
Hmm. So, given this understanding, would it be the case that ontologically the electrical process would be the explanation of how, say, like pure light binds itself into these discrete units that appear to us as particles?
Yes.
Mm-hmm.
Yeah, and it generally there is a slight difference of terminology, and this is something that I had originally reflected on for a moment, that of whether it would be more appropriate to talk about bosons and fermions, as because that's kind of the original uh, language which is used and talked about. But um, there is also more appropriately, I think, light and particles is something that maybe more accurately captures that distinction, because even when one talks about a field or a quantum field, or of a force, that still presupposes a prior conception of light, or of something that is free radiation. So, and I kept coming back to that I couldn't, uh there wasn't some other, you know uh, some other empirical concept that didn't, ontologically refer back to light originally, in that sense.
Mm-hmm. Yeah, that's interesting. Most most of the times, I would see it as people would probably think that I'm looking at here your outline, section 2 physics. They would put thermodynamics first and electrodynamics second. It's interesting that you
Hmm.
inverted that order.
Yes, and well, there's a few reasons for this. Number one, since I've already established and discussed the notion of uh, electrodynamics as part of, or light as something which is uh, essential and non-immediate, something that is always um, emitted, absorbed, reflected in its own activity. Um, this is something that, uh, in turn, as in order for the electrical process to actually take place, for say different kinds of particles to be produced and generated and combine in say where you have differences of uh, of uh, of energy levels that this in turn has to take place in some sort of expressed apparent setting where you know we're kind of going back to uh, almost going back to mechanics, but from a recollected standpoint, from something that is determinate or something that we've already determined as being in part light particles and its electrical process as something which is apparent in the appearance that there is something that we're not just looking formally in terms of the equations of motion which um, are there so to speak immediately, but we're also looking at how this is conditioned originally from the essence or the non-immediate part. So with thermodynamics, there's kind of been an interesting sort of interplay. Well, I say interplay. There's been a lot of conflict and fighting over the years since the beginning of what thermodynamics was even as a field. Like um, originally, if you look back to the history of thermodynamics, it essentially originated from Lambert, Biot, and Fourier, as they were originally looking into what heat was and how the conduction of heat, but there was also happening at the same course of time of the developments in uh, calorimetry and thermometry of uh, particularly of the theories of Laplace about ideal gases and you know reversible homogeneous processes and the role of latent heat with respect to volume and specific heats. And that kind of led to Carnot and his work about heat engines and the motive power of heat in um, in affecting work or mechanical work in the motion uh, of that system. But the way that I have it set up here is that you're considering the first moment where you have the thermal phase of the body, where implicitly these are not just any sort of ordinary bodies. These are just you have particles which are, so to speak, generally united with each other in uh, a kind of relationships of charge. So they not only have they not only relate to each other externally as bodies, but also internally as distributions of electric charge. And this is something which forms the background internally of the body uh, itself, where you know if it has different concentrations of those particles, there is a difference in density, but there is also a way in which density is expressed as the the body is cohesive, and uh, because each part is in turn uh, in motion and affecting the motion of each part of that of the whole, um, you essentially begin to have a notion of uh, temperature almost as being the reflexive opposite of this cohesion. And even when talking about temperature is not even just as not just as vibrational motion, but in order to actually uh, express that kind of kinetic motion, that in turn presumes a unity of bodies or particles which are each affecting each other, and so you are kind of talking about something which can be more or less like a crystal or something crystalline, or you have something that is um, more fluid, that in being able to compress it, uh, say, or not really being able to compress it, but it still like fills containers or other spaces. Um, or you can have something which is even more energetically free than that, like say a plasma or something uh, like this. Um, and with respect to uh, with respect to heat, uh, this is something that can only uh, appear, so to speak, if there are actually, say, some prior notions of density, cohesion, and pressure in between the bodies, in order
Hmm.
for there to actually be a real transfer of heat. So, uh, like with in particular with latent heat, you specifically have a basically a kind of energy which is uh, released or absorbed, that uh, which can cause a change of state without altering substantially the temperature or pressure. Like, for instance, there are, to concrete example, like there's a latent heat of fusion, like uh, basically like melting of a solid to something more like a liquid. And there's also like a latent heat of vaporization, like from or you have something like a liquid uh, being having a change of state to something more like a gas. And in order for this to actually, in effect, happen, there has to in turn be uh, the the bodies themselves have to have a specific heat or heat capacity. And this is something that is investigated on part of uh, well, it's originally what calorimetry was originally about. That there are different kinds of substances have different heat capacities, and something which can be uh, uh, heated, relative to the amount of energy that is applied to it, say like in joules, but that this in turn is something that depends on the actual temperature of the body, like degrees Kelvin or Celsius or what, and also per mass, since there is the the degree of resistance um, to the motion or energy supplied. Uh,
Mhm.
right. Uh, and this in turn is something that is expressed concretely as uh, in terms of the actual uh, dissipation of energy, which is actually relative to some process for obtaining it. Um, uh, and this is something that I think uh, can more concretely ground a notion of um, entropy as something which is uh, has to do principally with the dissipation of uh, the dissipation of energy to a a form which can no longer be purposed for that specific uh, process. And kind of uh, there are ways for processes for to be reversible in the mechanical sense. Uh, but I mean, even if you look at the original history and investigation into the concept, there was um, less of an appeal to formalism and more of seeing entropy a uh, as a special, uh, generally of uh, internal dissipation, where you could say the body itself becomes um, less cohesive, less determined. Uh, but this is something which presupposes some prior process that would even cause that in the first place. Looking back over
Let's see.
to this.
Sorry, I was doing something real quick. Uh, but yeah. Uh, Actually, can you explain? Let's move on to the chemistry. Can you explain that? How you go from that thermal process to the chemical?
Yes. So, in effect, this in turn recapitulates the logic in the sense of there is, in the first sense, a unity of the uh, inner and outer, or generally you can say of the electrical and the thermal. That, if for some chemical uh, to actually be for some type of element to actually be uh, uh, determined, it presumes a original groundwork of both electrical and a thermal uh, uh, interaction. Effectively, to just say that uh, the inner must be able to uh, reflect itself or express itself into something outer, and that thing which is outer also in turn um, uh, reflects the inner. And this is something that is originally, in terms of elements, you know, uh, there is in effect a combination of a certain uh, electrons and combinations of uh, electrons can only take place in certain uh, uh, energy levels that this is essentially to say that there is some number of allowed states which can actually take place, uh, and in terms of this is something that is um, formally it is deduced uh, from quantum mechanics, um, but there is also a another context in which this is something that is expressed, depending on you know what kinds of elements are even essentially uh, possible to construct, uh, uh, given what they are, uh, and you know, um, like as long as there is an element where there is a difference of charge, a difference of voltage between the electrons and uh, nucleus, there is in turn a um, activity of sorry, an actuality. The element itself is something that is something uh, actual, like you know and depending on, because you can kind of think about uh, there is a variation in the properties of the different elements that exist per their electronegativities. Um, but this is something that can only be a real or uh, existent parameter, uh, if there is some uh, difference between uh, a quantity of positive charges versus a quantity uh, of negative charges. And if you're actually uh, thinking about the types of elements which can even exist, um, if there is like the condition for the possibility of chemical bonding, that presumes there is some reason or condition for this to be so, and this condition is something that has to do with the differences of uh, between the electrons, between the nuclei, between the nucleus, that there is a difference in the uh, the nature of the inner attraction between elements themselves. Like if you have um, if you have a more neutral combination between the positive nuclei and the valence electrons, you have something that's more like an inert, a noble gas, where there's not really. Um, it's basically self-enclosed. It can be distorted under certain conditions, like if you supply a lot of uh, electricity to it, like like with neon signs, argon, xenon, um, and you basically have elements that are more fluid-like, the more uh, outer valence electrons they have. Like uh, noble gas is essentially a, compressible fluid, but you have like you know other forms which at room temperature are either more tend to be more granular or fluid. But with metals, you have the other you have something that is more crystalline, as like with metals are essentially in effect essentially crystalline elements where you have either something which is say like kinds of alkali metals which basically form kinds of ionic bonds where you basically have like uh, a crystal of different ions, or with something like a transition metal, you basically have a crystal of nuclei, but within that you have a sea of fluid or mobile electrons. And this kind of high mobility of electrons is something that in responding to an external magnetic field is something that can be uh, in supplying current through something, it's something that can be, you know, more conductive, more uh, magnetic, and uh, it's only in this sense that you're talking about something where the actual properties of, say, electrical conductivity and and also of how magnetic something is in the actual uh, say how that specific um, in a specific substance that like to even be able to discuss that it is required you know you know like if you know what the substance is and the properties that chemical properties it has, then these are in turn traceable to the logic of the actual um, basically the elements which um, make it up, but it can't it can't just be any sort of combination of elements intrinsic to the thing. If it is something which is substantial, otherwise it would just be like it would not be a thing proper. It would be like just a mixture of of two things that don't really have any necessary connection to each other. Uh, and this is something that is explicitly seen in the kinds of bonds that there are, like the metallic, the covalent, the ionic, um, which are explicitly generated from the differences in magnitude of electronegativity. Um, and there is out of all of the specific fields of natural science, um, I feel like this is just my opinion, but the kind of philosophical and speculative work compared to other fields um, is perhaps the most absent in chemistry. Um, I mean, of course, it, it is arguable, of course, that there is you know some original connection to natural philosophy, like in like particularly with studies of protochemistry and alchemy, um, which, by the way, is something that is not something I think should be historically dismissed, because there it was a necessary part of the development of science, and they weren't just like magical or woo woo type they were real experiments. They were real. It was a necessary part of understanding what chemistry actually was, as a area of natural science. Like the it's not just the science is something that is something that uh progressively develops and enriches itself over time as its history. That the fact that there is something new to discover, or that there are new um, moments in science's history. That, that depends upon the history of the concept, because the concept is the one cause of that thing. Yeah, like, in order
Mhm.
for there to be an effect to systematize, it has to be caused by uh, the concept. Um, but I would like to. I do need to investigate. I haven't investigated the speculative history of chemistry as much as the other topics, but which, you know, uh, I mean, is kind of understandable. Chemistry is something that is a in a certain sense, a deeply practical field of study, because it has just so many wide applications to various different fields, just just in terms of like just in industry and business. But uh
No, if I can comment on that, I think part of the reason why we haven't seen much speculative work on chemistry is that there is a widespread and completely baseless assumption when you look at the history of it, that chemistry is just practical physics, and the actual understanding is in you know left to the physicists. When you ask, what is a bond? Oh, well, the physicists really answer that. It's whatever particles there are, the ways in which we empirically see them connect, and that much. What is a particle? Well, the physicists will answer that. Chemistry is just left to this purely practical side, and if you look at it conceptually, there there is no basis for for this understanding whatsoever. Uh, you look at the early stuff from the 1920s and 30s of the modern incorrect model that we're still taught to this day in like middle school and even up to high school of the Bohr model, I think, of the hydrogen atom, which Bohr himself
mhm,
knew like it wasn't real. He said, well, it's just practical, it's functional enough, and yet people believed this was how atoms really were. Towards the more realistic valence cloud model, in which we still don't really know why they work the way they work. But the assumption is, oh, well, the physicists know.
mhm. Yeah, yeah, and I definitely think that as part of the at least in the history of science, there's also a history, so to speak, of um, you know, different um, approaches or paradigms that appear in the history of science that you know uh, have their own uh, epistemic assumptions about the way in which um, that field of study ought to be. Like, for instance, much of modern chemistry is something that is heavily informed theoretically, also, as you had said, by physicists, in particular, uh, the kinds of areas in which, standard quantum mechanics can be applied, which, and even as far as quantum mechanics goes, I should specify, like, generally, um, it is not something that really uh, exists on the conceptual level, but is really more just on the empirical level, in the sense that um, it is something which basically provides you with a way of calculating, um, say, how you would expect this, uh, say, quantum particle or quantum system in a very general way to, if you know the initial state, then and the and its parameters, then you essentially have a way of calculating in a more uh, probabilistic way uh, the the uh, the expectation values of that of the state in question, which I think there is a notion in which that kind of analysis is, of course, necessary, not even just um, for um, say like actual experiments in physics, but also just generally of just of like understanding what modality even is. Where like you have some things which are concrete um, uh, probabilities which are specified given what the conditions are and what the possibilities are, and you have a way of actually calculating what the values are, um, because of the way in which it is uh, set up. Um, but to even understand what that is or what's even going on, you need some notion of the concept which determines that. Like there is a tendency, I think, in uh, theoretical physics research that goes completely in the opposite direction of uh, moving towards a concretely specified concept, but actually goes in the opposite direction towards chasing after something which is, uh, you know, transcendental or prior, um, in the kind of search for um, this is particularly true in the search for unified field theories or uh, theories of everything, which are uh, proposed as basically, in effect, looking for a formal solution to understanding the scales at which certain laws or equations of physics actually work and operate, that that tells us very little about what the concepts in question actually are. Um, like it is absolutely necessary for there to be a philosophy of nature before we actually even know what we're doing with any sort of, say, uh, specific theories of like mechanics, of gravity, of electromagnetism, of thermodynamics, of quantum mechanics. That like to to have a proper uh, unity of those fields, it can't just be, you know, uh, brought together just purely formally or purely empirically, because though there is a the empirical always depends on the individual context or conditions in which that takes place, and so cannot be adequately the concept or universal. And at the same time, there in the more formal conception, you have uh, an emptying almost of content where it becomes um, way too general and way too abstract. And by abstract, I mean like um, lack of relationships, lack of determinacy, lack of negativity that can actually serve as an adequate contrast for the the uh, study and investigation of the field itself. And
Mm-hmm.
and I should say that you know uh, even though that I am uh, someone who is uh, trained in physics in just like the in the academic sense, and has uh, learned philosophy outside of um, academia. Like this is something that I've been doing, um, like essentially entirely myself. So, uh, you know, I think that getting other people, say, who are, even though I've collected a lot of information and notes about this, I think that um, also trying to find people who basically exist within the overlap of having knowledge of both physics and philosophy, as which is kind of um, a pretty uh, there are not too many people who really uh, exist, so to speak, in both worlds. Um,
Yep.
so this is just something that I've um, really just been uh, trying to figure out the structure of uh, on my own, and hopefully uh, I can get something to the point that is actually like can be published or can be like uh, you know uh, read. And the kind of way that I've been structuring it is like how basically how Hegel does it in the different paragraph numbers, and maybe like probably for the encyclopedia edition, including like remarks from different people, or different people in science would also be something something cool to have.
No,
But
yeah, man, it's a monumental task. This is what I think the actual engagement of Hegelianism as a philosophy is. As opposed to like a lot of people just see themselves as recapitulators who are just kind of carrying keeping the torch lit. They're not really lighting anything with it. They're just keeping it lit for hoping for somebody to come along that does something with it. And yeah, I think this is the kind of stuff of doing something with it. Like I told you before we started recording, that I had this idea like a decade ago when I first got into Hegel, in which I'm like, this is possible. I found out the basic form of how to do it, but the actual doing of it is actually requires a lot of reading, which is what happened that I quit reading when I found Hegel because I started focusing too much on Hegel. So it took away my focus away from all these things. But that people like you who do have that uh, wide reading background and the formal background are required to have the credibility for it, and to know the depths of the current paradigms at least. That's exactly what is needed. And the fact that you have some significant differences. I mean, they're not. Some of the orders are certainly different. Plus, you have the modern editions. That's the exact kind of stuff that's needed, and a lot of people just kind of just want to recapitulate things exactly within the structures that Hegel has, which I think is just kind of missing the point.
Mhm. Yeah, and the kinds of uh, changes that have been made for this edition, uh, like I don't make uh, I did not make any change that was not something that is basically like a last resort, or basically like there's no other way I can think about this, because this is actually where um, this is actually what the preceding concept or the prior concept actually implies or leads to. And this is mainly for two reasons. One being that my notion in applying the method is that there is essentially nature is recapitulating the form of and development of the logic, but uniquely has um, its own contents. So it's not just like uh, repeating the logic as such, but you know it develops the form and content of it in a in such a way that actually specifies the subject matter of what nature is. Um, but there's also the other reason that you know uh, when Hegel was originally putting together his first editions of the encyclopedia, uh, he was essentially writing the encyclopedia at that was basically up to date with the current empirics and uh, knowledge of the field of his time. That there is basically uh, there is a way of specifying the uh, encyclopedia within that moment. But the encyclopedia is also a historical moment in the history of philosophy. So um, it is the task, so to speak, of the uh, new generation of um, uh, philosophers and taking up the task of philosophy to essentially uh, grasp the whole truth of the subject matter in its development. Uh, and this is essentially the way or concept that is specified. Um, you know, and this and by the way, this is not something that to just to clarify something about people who may not know a whole lot about Hegel, that this is essentially the dialectic is something which is um, a priori. Uh, so it's something that is an activity that is for thought and thinking, and um, something that comes before the experience or phenomenon uh, of the thing, which it is pretty interesting for um, basically everything which comes after the logic in Hegel's system. There is You are dealing with something that is, you know, something that exists concretely or uh, experientially. Like we are natural beings. We live in nature. There is basically so many different um, kinds of things which exist objectively that we do not have uh, knowledge of originally from experience, that we in effect take the concept for granted, or take these concepts for granted, and think that we have knowledge of the thing that is essentially like that we have immediate knowledge of the thing just through the senses, or that it's our perception that gives us that, or that the fact that we have a structured uh, understanding. But like this whole development is something that um, uh, you know uh, all roads lead to Rome. It's like all experience or phenomenology leads to the logic or the concept. So this
Yeah.
is something that actually has to be is absolutely necessary for nature for something to be done, to actually get to the heart of the matter.
No, I completely agree. Like the whole project of Hegel is the project of philosophy. Hegel would be very disappointed to find out that there is a that his work became just known as another ism amongst a mountain of isms. He had to hope that people would recognize that he was going at the heart of the matter of philosophy itself. That philosophy, as such, is a science, the science of sciences. Uh, that there should be none of these quibbling doubts that a lot of people have about, so and so says this, so and so says that, and who knows what's right or wrong. With the logic that was supposed to be the settling of like a lot of those issues on the metaphysical side, uh, which I mean, as somebody's gone through a significant part of it, uh, he's got it. He, at the very least, one. I don't think anybody who goes through that process could deny that this is the process. Perhaps you could quibble about, maybe you got this determination here wrong or something. There should have been another step, or you could skip this step or that. But the process itself is guaranteed, and like the beginning itself is also like pretty guaranteed. There is no other way to do it. And from that, if once you can settle that, a lot of this other stuff is settled, at least as far as the process goes. Again, and of course, one of the things is that Hegel is. I don't know if the other German idealists came up with this. They might have, but I'm not entirely sure about the whole realization that the view of abstraction that regular people have, that's common, is backwards to how it actually is. That the things that people think are concrete ends up being the most abstract things in reality. And that the mysteries that we think that are just like so complex, it's backwards. It's not that they're actually mysteries or that they are complex. It's that there really is nothing there to be said. There's that famous Zizek quote, space is literally the most stupid thing there is. And it's true. Space is not a complex thing. There's not really much of anything to say about it. All these things that physics, wrap themselves around, 23-dimensional strings and whatnot to try to explain just like, how a thing is outside of another, is just this nonsensical way in which we have made the world mysterious to ourselves in our own ways of framing it. But it's not mysterious in and of itself. Stuff like physics, in which, people think that, take for example an apple, and they think like, oh, the reality of the apple is like these trillions upon trillions of particles, that we could just reduce to, like quarks or whatever, or some simple little field equation. But, the simplicity of, what an apple is ends up being this ungodly, endless equation of this simple thing repeated over and over. And in the end, that it doesn't even add up to the apple anyways, because what we want to say about the apple can't really be summed up with numbers. So, I think in a lot of those ways, what you were saying, that, that a lot of people take for a lot of these concepts for granted that aren't actually immediate at all. Like, oh, well, gravity, we know about that. Matter, we know about that. But when you actually look into it as to what the experts themselves say, the experts in physics at the very edge of it will all admit, yeah, we don't know what these things are. Yeah, we're not entirely sure what matter even is or what space is. But beyond that, everybody just talks about them like we just know. Like, well, we have an equation. We know what gravity is. No, we don't. And the main thing is not that they are so mysterious, so much as like we're just confused about what we're even looking at, and we've defined ourselves into these very strange, contorted boxes.
Mm-hmm. Yeah, I completely agree with that. So I guess I could maybe while we have some time left, I don't know if you wanted to continue that, because there's basically like
The
I could
organic
talk a little bit
section.
about the organic section. Yeah.
Yeah, let's go.
Yeah. Yeah. So essentially with organics, you know, proceeding from this, you have something that has the structure of the concept because it originates from the chemical process as something that is unconditioned, that it uh, rather than simply being like two products that or two reactants that react with each other and form products that in turn become uh, reactants for another process and so on. That we have a way of understanding, because each of these chemical processes in turn depend on each other, and in either absorbing heat or releasing heat, or absorbing electrical charge, or absorbing light and releasing light. This this becomes organic when you actually have a notion of a concrete process or cycle that instantiates the essential moments, or as part of its own activity. So, uh, although cosmologically speaking, there are various chemical processes that, of course, exist and are necessary to condition uh, the process for, say, something which is, a chemical process on uh, different planets, but only something like uh, the Earth uh, can maintain itself as a organic uh, uh, unity, because it is particularized or divided into um, different cycles of its own activity, like particularly of the atmosphere, the hydrosphere, and lithosphere. Uh, uh, Effectively, the process um, by which the planet or the Earth has an atmosphere which is essentially mediating itself, or in turn protecting the other processes, because um, if it were absent, there would be uh, effectively no way for uh, the planet or Earth to essentially absorb radiation and to effectively maintain uh, the energy necessary to carry out its organic activity. But if you had an atmosphere that's way too dense or thick, then you have something that's basically like the hell world of Venus.
Hmm.
Uh, that there has to exist a basically it has to be able to sustain itself and has its own activity, and also basically protecting the other parts of the other cycles of its self maintenance, like the in particular, like uh, the hydrosphere is also in effect being responsible for um, uh, essentially providing a way for other chemical reactions to take place, which require essentially a solution, like a certain, um, in particular, like to be able for certain materials or elements to dissolve in something, that requires a medium uh, in order to dissolve into. So there's an interaction both with the lithosphere elements and like erosion, weathering, things like this, but also in the interaction of the hydrosphere and the atmosphere, as you have processes of weather. You have uh, the formations of different clouds. You have uh, you know with the Earth and having a certain proximity to the sun and its own revolution. It has seasons and uh, you know different distributions of temperature on its surface. Uh, which there is the Earth is a concretely self-sustaining unity in that sense, and to also for its uh, specific or determinate constitution, like in particular, like what it's made of. Like you have a way, or the Earth essentially has a way of producing and reproducing kinds of minerals through this activity uh, via, with a volcanic activity that that releases lots of um, there are various kinds of metal elements within the mantle within uh, the Earth, which you know are lava and magma, which cool and melt, and this in turn becomes subjected to the eroding and weathering process of uh, the air, the atmosphere, uh, the oceans, where it becomes different kinds of sediments which accumulate in various layers over its history. And this also, in turn, becomes something that, as layers begin to accumulate and form, there is, increasing pressure from the different layers as pulled inward by gravity, that under conditions of various temperature and pressure cause essentially new reactions to form and to take place, which it is essentially recycled and back through the crust and the mantle, where the process kind of uh, rebuilds itself again through this activity, which if you treat that recollectively, you almost have you have a sense of a metabolism, or you could um, say almost like a proto metabolism of the Earth itself. Um, and this is something that actually has to form in some way as being a groundwork for the new uh, the genesis of life. That in order for uh, there is a certain interesting development in the uh, notion of what uh, life even is something which is uh, basically in the first sense um, difficult to define in the formal sense, like in the ways that basically like the kinds of textbook definitions that are given of what something that something that is living is. You have notions of metabolism, of growth, of reproduction, of
Homeostasis.
homeostasis. Yeah, all these different things. But you can't just formally uh, state this by way of uh, listing definitions. You have to have a way of describing what uh, life is conceptually from its own standpoint, such that logically we would have to say that there is some that it would even be rational for uh, uh, life to take place uh, to begin with in something that originally has its groundwork in something that is uh, uh, basically organic. That as far as notions into uh, conceptions on the origin of life, I think that the the kind of first thing that really needs to be done in approaching that topic, of course, is to even have a synthetic or concretely specified notion of what life even is, and to understand why it is necessary and not something that is just sort of hand waved away as a miracle, or something that's just, oh, it's just something that accidentally happened in in nature. That is like, no, if you actually investigate the concept of what life is, you know that it had to had to happen, right? Like the notion that um or that nature is something that is purely capricious or random, although there are events in nature which are uh, contingent. There is contingency, but it's the undue uh, absolute making absolute this notion of contingency as a mode of explanation that does not really get to the actual heart of the matter, which uh, um, and although I'm not an origin of life scientist and would not admit as much, I do think that um, the most plausible notion is that you can think of the Earth almost, if the Earth is like a proto organism, you can almost think about the hydrothermal vents, because the Earth, if you think of something as an organism or as a proto-organism, it has to have organs and I think that um, the activity of uh, hydrothermal vents is almost, you can almost think about it as um, basically the period through which the Earth was basically uh, fertile in that sense, and providing a way or means by which um, life uh, uh, or more advanced life developed from that standpoint. Which you
Hmm.
need something that is autocatalytic, that it's something that is constantly reproducing itself and interacting with its environment, that it is actually the subject, or you could say soul, of its own process. And it has to have a way of carrying all of these processes out. And at least from this uh, standpoint, you actually have a transition into the biological, and the biological forms of life that exist. And at least in the way that I've conceptualized this, is that there is, in effect, um, microbial life, the very simple cellular forms of life, and the kinds of archaea, bacteria, as basically its form of interacting with its environment and reproducing itself is very mechanical. Like, it basically just reproduces uh, asexually. It has horizontal uh, tr transfer of genes, and basically, that this has kind of led to the idea that especially with the kinds of organisms like bacteria and protists, as well as fungi, mainly the uh, asexual kinds of organisms, is almost in a sense being um, basically the same kind of entity that has existed since its uh, conception, since it's basically creating copies of itself. That you don't really have a differentiation of the organism, properly speaking, into various kinds, because its um, mechanism or means of self reproduction is so simplified. And it's only with the kinds of organisms such as plants, that you not only have something that is uh, independent, in the sense that it independently derives its energy from a source which is not predicated on simply consuming other life forms, but actually incorporates within itself the elements of the inorganic, like minerals from roots, and water absorbed through leaves. That there is essentially a process of vegetation, and that vegetation is essentially the passive growth, which involves and requires the assimilation of the inorganic into the organic. And in order for this to actually be carried out and to actually develop, you need to have some form of reproduction, which does not simply create copies of itself, but is actually functional, or actually functions to create another organism uh, that is of its kind. So you have, strictly speaking, a greater differentiation of the kinds of organisms that the kinds of flora, kinds of plants that exist because of uh, vertical gene transfer in the way of sexual reproduction. But it's the kind of sexual reproduction for plants is quite different from that of animals in the sense that for plants, it basically has its male and female gametes already growing out of itself. But like in terms of like pollination, that there is the sense in which the pollen is uh, serves to fertilize the origin towards the growth of uh, the seed, and the seed is released, and from that grows the next generation of plants. And it's interesting that with plants you can actually see an alternation of um, certain phenotypic traits, like with between like generations, like with Punnett squares. And
Mhm.
it's because there is a process of sexual reproduction, but with plants it is very simplified. You know, where if you have something a more inwardly purposive, being like the animal has um, uh, its division of reproduction is on part of the being of that organism itself, where you actually have a division of male and female organisms, and not just of male and female organs, which are in and of, you know, for plants, that's basically part of the same plant.
Mhm.
Um,
Now, there's also that interesting thing about
which,
plants that
there's
they
a
lack
much
individuality.
greater uh, diversification of animals, even compared to plants, because with animals there's not only that activity of uh, sexual reproduction with its own kind, but there is also the animal is uh, has a greater degree of freedom and self-determination than the plant has, because the animal isn't just passively growing new organs as a part of itself. Its organs are already there as constituted as part of the whole animal organism. That, there is a differentiation of its functions into, different organs that are responsible um, for like basically like the skin, protecting the organism from the environment, the kinds of structures that support um, mobility, like the skeletal system, muscles, and the various kinds of organs that exist for uh, processing food and nutrients, uh, as well as reproductive organs, and as well as a unified subjectivity in through the neural system that is, coordinated and united with a brain or center of uh, where you have a new level of subjectivity Whereas with plants and also with microbes, you essentially had a basically a more free coordination of uh, cells, which, you know, are autonomous units, but that coordinating activity was basically either just determined in and through, the organism being a copy of itself, as in the case of a microbe, or was generated from the embryo or from the seed of the plant. But with the animal, you actually have a a new um, center for coordinating its the activity of its organs. That the organs aren't just something that are uh, basically aren't just interrelated to each other as basically budding and germination from uh, different parts of the plant that are capable of growing out of itself. But with the animal, it has a very uh, specific kind of you know genetic plan, so to speak, of how its organic being develops in the different stages of its life cycle. And and this actually gets to the last part of the which is uh, changed from the original philosophy of nature, but I think the structure of where you have the geological or sort of the notion of the environment as and also the biological as well, which is the actual uh, organisms which exist within this environment. Then, with regard to ecology, you are basically recollectively treating the whole process of the genesis and lived activity of the organisms, their uh, specific the way in which they develop themselves into the different features of their anatomy through their lifetime. Uh, Basically, and this is particularly true. While true generally of organisms, it's most true for animals because with animals, they specifically are the most complex and so are also suited for uh, forming a specific kind of niche within that environment, um, which also necessarily involves relations to other organisms in that environment, whether it is the prey of another uh, animal or if it is itself a predator of another. And this is something that uh, Hegel actually explores a little bit in his discussion on animals, specific that uh, the way that in which different species that you can almost see animals as belonging to different species. Interestingly, the way that Hegel describes it is that uh, it's almost as if each animal species has its own unique kind of specific developed organ that is not only specific to that niche, but is almost a protective weapon for it. Like he talks about with rodents, this is like with their teeth, uh, like with tigers. Basically, tigers and lions, they have their uh, strong claws. And you know different animals will be developed in different ways per um, not only inwardly per the their genetics, which actually specifies what kind of trait that is to be expressed, but also at the same time, when that trait is expressed, that affects other organisms and also affects the environment that affects other organisms, that there is um, at the same time a way in which the organism changes or develops itself in response to the environment in which it exists and to the other organisms that it interacts with. That is, you know, purely not just in the way of um, not just that's not just sort of done uh, randomly or after the fact with mutations. Although mutations do are important and they do indeed uh, uh, happen, but there has been an increasingly a view of phylogeny and of uh, evolution of organisms generally, which has almost a too mechanical understanding of the topic, where it just sort of basically treats the gene or the genome as basically the subject of that process, um, for the cited reason that the genes are originally what code for the kinds of proteins in the forms of tissues and cells which express those traits. But uh, at the same time, this uh, neglects and ignores how those traits themselves develop and change uh, within that environment as effectively in not just in a genetic way, purely through sexuality, through the embryo, but also epigenetically in the way that interacting with the environment and the cell taking in certain compounds, it causes certain genes to be expressed or effectively the kinds of genes to be turned off and on, which this would be something that is implied. This would imply that the gene itself is not actually, in truth, the true subject evolutionary activity at all. That though it is a necessary part of it, um, the gene is not simply like, a program that controls deterministically how the way in which that organism is supposed to um, uh, develop itself and speciate.
Right, right. Like that whole idea just doesn't ultimately make any sense if you just look at the reality,
And
right?
I can get into more detail about that. I
Uh,
need to get some water
can you
though.
hear me?
I can hear you.
Oh, okay. Sorry. Yeah, yeah. Go ahead. Get some water.
Hold on. I think there may be trouble on my end or on yours. With I'm gonna try coming back in just a second.
Can anybody else hear me? Hello. Oh, okay. So yeah, while he's gone, that whole thing of like the selfish gene idea doesn't make any sense. If that was the ultimate aim of life, then um, the whole idea of evolution would just like not really exist. You know, the things that would have evolved would have been just basically entirely viruses.
Hello? Oh, sorry, I'm
Uh,
back now.
all right, can you hear me now?
Yeah, I don't yeah, I think there was just an issue on maybe it was my end. I probably my end, but anyway, I'm here.
All right. Yeah, so what I was saying is that the whole idea of the selfish gene just doesn't make any sense. If that was all that nature was aiming at, then we would basically just have a world of entirely of dead viruses, uh, or
Yeah.
cancer. Either way, like it would just be a dead world. That doesn't make any sense. The whole idea of the individual uh, organism being the ultimate aim of evolution also doesn't make any sense. In that the individual's own survival doesn't. If that was the case, we would just basically have the evolution of a war of all against all, in which the conclusion would be a dead world. On the
Hmm.
microbial scale, you wouldn't have gone beyond that. The whole idea of multicellular organisms wouldn't even make sense.
Yeah,
Um,
exactly.
so, like, whatever the principle of evolution is, it is really the subject must be, yeah, ecological in a sense. It must be something, one that goes beyond a single organism towards a species, but even more importantly, it goes beyond a singular species. It goes between multiple species that are somehow being coordinated by their nature to come together harmoniously.
Hmm. Yeah, and I think at least going through this part in nature, it provides I think at least as far as uh, theories of evolution are concerned, that there is essentially not just one level or moment that is determining how the organism um, develops as a kind and produces, offspring of its kind and speciates as in response to in different factors. Like there is not only its uh, there's not only the level of genetics, it's the genome of the organism, where there are mutations which can indeed contingently take place, but that's not the only thing which can cause uh, organisms to change. That, you know, in response to its stresses in its environment, that can also cause make it harder for organisms to reproduce, or there becomes a conflict between um, populations of different organisms, where, because there's essentially a rate at which uh, one kind of organism or animal consumes other animals of another kind that it has a predator-prey relationship with, that can lead to overpopulation or overabundance of organisms, as well as uh, underpopulation of in and both producing conditions which um, can cause an alteration of its niche. But beyond environmental pressures, there's also uh, epigenetic uh, uh, pressures, which does indeed provide some credit to uh, Lamarck in, in having structures of use and disuse, being particular to a certain uh, niche which is selected for. But this is something that can only be actual in relative to environmental um, stresses, which um, are themselves either uh, natural, in the sense that the environment or climate of the habitat is changing, or it's responsible for, say, a new species which is introduced, or a species that is key to that area is has migrated. Um, but that ultimately there is a more systematic way in which the evolution of species uh, can actually take place, and that this is also something which is different for different kinds of uh, species, like the way in which uh, an animal uh, inherits certain traits and uh, is developed towards a certain species, is not at all the same, and that of as say between different kinds of plants, or different kinds of like bacterium or whatnot. That there's not a general sort of uh, principle which applies the same to all organisms, but actually takes place differently, just simply because of the fact that they have functionally different structures, both of their genome, their genes, as well as how those genes are even expressed in the first place.
Yep. Sorry, just got a little disruption, but yeah. So like, let's finish off with spirit. How does this lead us to spirit? Because the way I interpret it is, we can have the whole relationship with geology. We can see how that leads up to the conditions of life and how life then in ecology turns around, repurposes geology to itself. Because a lot of people just think about ecology as kind of a relationship between life and the environment, the inorganic environment, in a way. Uh, but ultimately, ecology just is like the relationship of life to life, because the geology just becomes subsumed under it.
Hmm.
It's changed in various ways, and then life is what maintains it in its specific modes. And so, with life, we have this. I mean, Hegel takes it as it's the highest instance of the idea of something which is a subject, which is object for itself, that produces itself as the thing that it is. And the only thing that life fails at, that's not quite perfect, is that it's still in the realm of externality, that it's still dominated by the structures of objectivity in which, life cannot perfectly subsume itself into its own world, because it is still a body in space and time. It can be corrupted by other bodies, it can be destroyed by other bodies. Uh, and ultimately, the absoluteness of reality cannot allow for this fragmented nature. Uh, Certainly, it exists on the level of life, but the universe itself can't suffer this. In a way that if we take it to the at this level of the concept, the universe itself would have to be one giant organism, a living thing, but that it cannot really be understood merely as that, because unlike the finite living things that we are, uh, this one living substance, let's say, uh, doesn't have an external relationship to any other living substance. It doesn't have anything else which would corrupt it from outside. And to say, well, it would be corrupted from within doesn't make any sense. Because all that it is within it is its own living process. And it's this absoluteness in which there is no externality for the universe, concretely as a whole, as this living process that constitutes the beginnings of spirit, right? That as opposed to nature as this self-external domain, spirit, mind is the reverse of that, the externality of externality, which is absolute internality.
Oh, yes, yeah. I completely agree with that. And that's essentially basically how I was thinking about it as well, that you know, the development of the natural cannot simply um, you know, even though that we do have a progression towards more complex forms of life, um, there is an an inherent limitation to this, um, for a few different reasons. Um, that the limitation is that there is uh, only so much that the organism can actually be adapted to, in the sense that it is still, as a completely natural being, is still determined by those the relationships that it still has to other natural beings. Like, even though that the animal is comparatively more self-determining, more autonomous than prior life forms, there is still a sense in which the animal is bound to a certain natural necessity per the its specific instincts and specific niche and specific organs that it's that developed to realize that. And essentially, what is the only way that there is a further development? Well, there must not only be an evolution of say the body, but also of the mind, the intellect. That there ought to be a way in which the natural produces or creates the conditions for um, the development of the internal or the mental. That nature uh, is or the living being is something that persists in is perpetually caught up in this recurrent loop of the natural, that because of the whole uh, idea of an organism as something uh, uh, finite, which something that intrinsically um, must die on its own account. That you also have uh, uh, the the evolution and development of organisms and of natural beings requires this element of you know uh, death. That death is a part of the intrinsic process by which the old uh, organisms uh, essentially die off in order for the new forms of life to take place. That there is actually a inward uh, development on part of the natural uh, to make it in this way. Um, that uh, in developing a more internal sense in which uh, the natural being is developed, that it becomes something which is truly individual and results in the true notion of consciousness, of a kind of being that is capable of thinking, capable of reflecting on the universal.
Hmm. Yep, makes sense. So yeah, we got through the whole thing. Uh, Unless we have some like final remarks, or want to do a little bit of recapitulation. To repeat what I said at the beginning, and we discussed a little bit in the beginning and also in the middle. This kind of project is absolutely necessary. Excuse me. In order to get ourselves out of a lot of the scientific messes that we're in, if you're kind of like in the academic space of theory, it's likely that you are aware that for probably about the last decade now, there's been a rising discussion going on about a crisis in this or that science. Particularly, there's been a crisis in psychology. There's been a crisis in biology. People are starting to talk about crisis in physics. Really, it's just a general rising crisis in what we call science everywhere. And that general crisis is not just simply a crisis of replicability. It's not just simply a crisis of seemingly no new novel understandings that are paradigmatic revolutions like we saw a century ago. A lot of this crisis is just a confusion born out of really bad basic concepts. Now, one of the cures for that is simply just learn to do a little bit of self-criticism in philosophy, and you can easily find out how to tear apart almost any of these systems conceptually, because they don't ultimately make sense. But that doesn't leave us much of anywhere. That just leaves us, stuff works, but we ultimately don't know why. And I mean, if you kind of get to that, you basically have given up science, which it seems that a lot of people are heading towards, from what I see. The idea of, say, for example, AI doing science is literally just the idea of giving up. It's literally just like you give up any notion of why or a real physical material how. Just accept that there are correlations. The machine will do the correlations for you. And, undeniably, AI can find correlations that work. Just like epicycles worked for, 1,000 or so years. For celestial phenomena. But, after the fact, we know that epicycles just aren't how it actually works. But they worked. A lot of people don't remember that. They go like, haha, epicycles, not paying attention to the fact that the reason epicycles were used for so long is that they literally worked, and they worked damn well. We're in a time in which I think a lot of science has become basically epicycles. Fake explanations that work. They work well enough, and since people have been sold this idea that science is justified in all its weird claims and beliefs because, your computer works, your internet works, your cell phone works, your fridge works, therefore, don't question us, we're the scientists, we say some crazy shit, yes, but hey, since the stuff works, reality must be that way. Well, with AI, stuff is just going to get even more like that. It's going to be like... One of the craziest examples is that there was an AI trained on examining tissue x-rays of like brain cancer or something. And the AI obviously got to a point in which it could diagnose from an image better than any human expert. When it was examined as best as they could as to what the AI was actually doing that made it so good at diagnosing. What they found out is that the AI had grasped onto a correlation between the data on the images regarding like the machines and dates that these images were taken from. It just happened that certain machines were better. And since these were trained on backwards data that was already verified by real people from real cases, it had happened that certain x-rays from certain machines at a certain time had a much better quality of results, so that the machine had made these correlations, and when shown images related to these machines, it was actually able to use that correlation to make some pretty good predictions as per diagnosis. So it wasn't that the machine, well, the AI understands anything. It's just it grasps a correlation that no human would ever grasp on as being meaningful. It worked, but it isn't a very meaningful correlation. If we end up going that way with science, say goodbye to any understanding of the world. Really, all you're going to have is stuff that works, and nobody knows why it works, even though it's basically like correlating the itch on my foot and storms on the red spot on Jupiter. Maybe there is a correlation, but why is there a correlation? What does it actually mean? Who knows? Doesn't matter so long as it works. So we really need not just a critique of concepts. We need to have an understanding of nature in which we can put things together positively. Because this haphazard way in which science has been working up to now, again, it works as far as practice goes. We can make things, but then people are also deluded about the fact of why this happens to work. It's like riding a bicycle. You and I can ride a bicycle, but it doesn't mean that we understand the physics going on in the motion of the bicycle itself. Doesn't mean that we understand how to actually construct a bicycle, how to like understand the stresses on the body and whatnot, the engineering stuff. Same thing with cars, for example. Plenty of people seem to be able to drive a car, and you can even replace parts in your car, but it doesn't mean that we understand the fundamentals of combustion in a combustion engine, or electricity in a battery-powered car. So, anyway, stuff like this that Avalonia is doing, absolutely necessary. Though nobody's paying attention to this kind of stuff now, there will come a point, I think, in history where people just get tired of this haphazard pseudoscience, and I will call it pseudoscience because that's what it is, in which, because we're blind to what we're doing, we're blind to how reality actually works, we're blind to how we actually relate to reality through concepts, we're blind to what concepts are fundamentally, we get ourselves into these terrible confusions, which historically it's understandable, but we're at a point in which we've had people come along that have figured this stuff out. So it's better to get on it sooner than later.
Oh yeah, absolutely agree. Yeah, and just one side remark. I think it's at least kind of interesting, at least with where uh, the form in which uh, the philosophy of science is now and more recently, where in a lot of ways it's a skepticism which has arisen out of the failure to grasp and come to terms with Hegel, or a speculative philosophy. That, if you ask someone in the so-called uh, dialectical materialist tradition, they might give you, say, a vague picture of you know some notion in which the method is might seem to be applied, but simply does not really uh, seems to kind of be more nominalist about concepts, and just tries to kind of treat the empirical as something that is dialectical, which is something that cannot work. Just uh, and you can find many different examples of how and why this does not work. Just read anything that Engels wrote. Uh, so, but there's also tendencies within the corpus of generally the uh, the positivist tradition of people like Karl Popper, Russell, Carnap, who in a lot of interesting ways is almost uh, because there is a skepticism about the method in general. There is just kind of a very slim kind of criterion which is given for science, like just the whole criterion of uh, you know falsifiability and the whole notion of uh, trying to make it be uh, trying in different ways to uh, make it conform to a certain uh, formal system or philosophy of language that does not uh, work, um, or is not intelligible. Um, it may quote unquote work in the sense of doing stuff with it, but um, what's kind of ironic is that at least with a lot of these new skeptical interpretations of science and natural science, is that it does actually much less to explain something of what nature is like to the average person, where there's immediately kind of a confusion in getting people to accept certain uh, presuppositions when you know nature just tells you what nature is all about. There's no uh, presupposition there because it's uh, already a self determining total system. Like people can invent all different kinds of you know fake metaphysics or fake religions to or uh, methods to try to come to terms with it, but uh, eventually they're as was kind of mentioned earlier that everything leads back to the logic. There's just uh, that's where all of those um, roads ultimately uh, lead to. And to actually be a true skeptic is to essentially just to say, I'm not just going to cast doubt on just any sort of claim about nature that comes my way. No, I'm going not only going to be, you know, self-critical, but also try to investigate, really objectively what nature is.
Yep, that's exactly the issue. I mean, you've been around, you've talked to probably more people than I that are annoying. Like, they just don't accept what they see. Like they're in denial. They're like, no, the mind can't be, an actually ontologically different thing. When I see red, what it really is, it's just these like abstract wavelengths, of matter. And you're like, yeah, sure, that's involved, but that's not what we're talking about. That's not what we experience. Like, oh no, it's an illusion. The real thing is this other thing. They
How do
don't
you
pay
know?
attention. They don't pay attention to like how ridiculous it is and like how much more complicated they're making it than just accepting what it is that we actually experience and see.
Mhm.
All right, but anyways, yeah, thank you for the interesting discussion and explanation. As you work on this more, hopefully we'll get into it into more detail the next time you end up updating it. But all
Yeah,
right.
I should have, yeah, should probably, uh, if everything goes well, probably should have the next update up next month, hopefully, because I am getting to the point where I have a lot of the work done. It's just like uh, you know, putting it all together.
Yeah, all right. So, anyways, that's it for today. For those of you who listen, you have any questions on this on YouTube, for example, go ahead and post them and or join the Discord, the Imperial Trail. All right. What in the world? Ah, okay. Sorry, I have this weird setup on Windows where like I couldn't tell where the window was. All right, that's it.